We have a question here that's asking us to construct vectors and then represent some vectors as sums of other vectors. Now, to do this, we need to create an origin. And the only thing an examiner wouldn't give you credit for is if you created an origin on one of these actual spots. Anywhere else is fine. But if you created the origin on one of these actual labeled spots, then the amount of work you would need to do to answer this question is less than the correct answer, and therefore an examiner wouldn't give you marks. So I'm just going to pop the origin out here somewhere, and then we will make some vectors relative to A, B, and C. So my vector from O to A looks like that, and that's A. From O to B, let's try and make that a little bit more accurate. Looks like that. And from O to C, again, probably better if I draw it as a straight line. O to C is going to look like that. Now, I have to express from O to G in terms of A, B, and C. So what I need to do is I need to find out how I can move from either A to G and make a sum. One way I can do this is by moving from O to A and then A to G. And I can express that both visually as I've done, geometrically, or algebraically. So OG is the same as OA plus AG. And AG, this vector here, is absolutely parallel to this vector here, from B to C. You can see they're identical. So AG equals BC. And then again we're going to make another substitution, because BC equals from B to O, and then from O to C. So this is all our same vector. These are all equal. So therefore, from O to G, that equals from O to A, and we know that's vector A, plus from B to O, well, that is the negative of vector B, plus from O to C, which is the positive of vector C. So therefore, my vector OG will equal A minus B plus C. The second part of the question is going to be similar, and I need to express from C to D in terms. We'll do this one in green. From C to D is this straight line here. So I need to somehow represent it because it's also equal to BG. So the first thing I'm going to write is that CD equals BG. And now I can work with BG, the known vectors, to be able to calculate that. So to do this, I can go from B back to the origin, out to A, and then up along our vector, which is our answer for the first question. So that's what I'm going to do. When I move down from B to 0, that is negative B. Then I'm going to move across from O to A, which is A. And then I'm going to move from A to G. And I'll write that as my vector. Now I know from this previous question that AG equals from BO to OC, or negative B plus C. So I'm going to substitute my value of negative B plus C into this side. And so I'm going to get BG equals negative B plus A minus B plus C, or A plus C take 2B. If you found this video helpful, please subscribe or like. Thanks.